top 10 tractors that could tow entire buildings. Across the world's largest farms, construction sites, and remote industrial zones, there exists a small class of tractors built far beyond ordinary fieldwork. Machines with frames as long as buses, engines borrowed from ships and mining haulers, and enough tractive force to pull loads measured in hundreds of tons. Most agricultural equipment is designed for soil preparation, seeding, and harvest. But the 10 machines in this program have crossed that boundary. They can haul implements so wide they block an entire road. They can tow prefabricated building sections across soft ground where trucks would sink. Some have been pressed into service-moving oil rigs, bridge modules, or derailed train cars. Each one represents a peak in engineering, more horsepower, more torque, and more ground contact than almost any other wheeled or tracked vehicle in agriculture. They are not experimental prototypes. They are working machines, proven in real conditions, and still earning their keep. Over the following 10 segments, we'll examine their design, their capabilities, and the environments that demand this level of power. From the most advanced high-tech platforms in current production to legendary one-off builds that will never be repeated, this is the definitive list of tractors that could tow entire buildings, and, in some cases, already have. Ranked 10th, Fendt 1050 Vario. By the mid-2010s, high-horsepower agriculture faced a design challenge: how to combine the pulling strength of a heavy articulated tractor with the transport speed and maneuverability of a conventional wheeled machine. Large farms, especially in Europe, often needed to cover dozens of fields scattered over a wide area, with frequent road travel between them. Traditional articulated tractors could deliver the power, but were slower, more fuel efficient at transport speeds, and less suited to tight rural roads. The Fendt 1050 Vario, unveiled in 2015, was engineered specifically to solve this problem. A single platform that could work like a field powerhouse and still cruise like a transport unit. At the core of the 1050 Vario is a MAN D267 6-cylinder, 12.4-liter diesel engine. Twin turbochargers deliver a peak of 517 horsepower under the ECER 120 standard. But what sets the power plant apart is Fendt's low engine speed concept. Maximum torque is produced at just 1,100 RPM, allowing the tractor to pull heavy draft loads without running at high revs, reducing fuel consumption, lowering noise, and extending engine life. This torque is channeled through the Vario Drive CVT. This continuously variable transmission actively manages power distribution between the front and rear axles, removing the need for manual range changes and improving efficiency during both field and road work. Tested at the Nebraska Tractor Test Lab, the 1050 Vario recorded a maximum drawbar pull of 35,765 pounds force, 159 kilonewtons. While this figure sits below that of the largest articulated tractors, it's exceptional for a fixed-frame design that can legally travel at up to 60 kilometers per hour on public roads in many European jurisdictions. In real-world terms, this means the 1050 can deep-till heavy soils, operate ultra-wide cultivators, and haul fully loaded grain carts. Then hook up to a low loader and move industrial equipment or prefabricated building sections between sites in a single day. Chassis design is critical to that versatility. The 1050's fixed frame offers stability at high speeds, while its long wheelbase and intelligent ballasting system provide consistent traction under load. The front axle suspension improves comfort and control on uneven roads, and large diameter tires minimize slip in the field. The result is a machine that can transition from precision seating to high-speed transport without swapping platforms. Inside the Visio Plus cab, operators have 6.2 square meters of glass for maximum visibility. The ergonomic armrest integrates the Vario terminal touchscreen, which controls everything from hydraulic flow rates to guidance systems and ballast settings. isobus compatibility, load-sensing hydraulics, up to 430 liters per minute, and factory-fitted GPS guidance make it fully compatible with advanced implements and precision agriculture practices. In the marketplace, the 1050 Vario sits in the premium flagship category, New units often retail between $500,000 and $650,000 US dollars, depending on specification, and their resale value remains high thanks to reliability, build quality, and fuel efficiency. Competing with the John Deere 9R series, Case IH Magnum 400 Plus, and CLAAS Xerion 5000, the 1050 often wins contracts where both top-end field performance and high-speed road travel are essential. A decade after its launch, the Fendt 1050 Vario is widely regarded as the benchmark for high-horsepower standard tractors. It embodies a design philosophy that rejects compromise, offering the pulling power to handle the heaviest cultivation work and the speed and comfort to function as a transport leader. For farms and contractors that demand year-round versatility without sacrificing performance, it has become a defining example of what modern agricultural engineering can achieve. Ranked 9th, CLAAS Xerion 5000. In European large-scale farming, power alone isn't enough. Fields are often smaller and irregularly shaped, separated by narrow rural roads, bridges, and village lanes. Contractors may be expected to haul silage one day, deep plow the next, and spend the winter clearing snow or operating forestry attachments. The CLAAS Xerion 5000 was conceived as a machine to master this multi-role environment, delivering the muscle of a high-horsepower tractor with the adaptability of a modular work platform. At its core, the Xerion 5000 is powered by a Mercedes-Benz OM 502 LAV8, a 15.9-liter twin-turbocharged diesel producing up to 530 horsepower and a torque curve optimized for heavy draft loads at low engine speeds. The powertrain is coupled to a continuously variable transmission, CVT, a rarity in tractors of this size class, allowing seamless speed changes from under 100 kilometers per hour to 50 kilometers per hour without shifting. Permanent all-wheel drive and equal-size wheels on all four corners ensure consistent ground contact and traction, whether in the field or on the road. One of Xerion's defining features is its rotating cab system on the Quadtrac C model. In less than 30 seconds, the entire cab can swivel 180 degrees, letting the operator face rear-mounted implements directly. This improves visibility and control when pushing silage, operating snowblowers, or handling forestry equipment. It also makes the tractor exceptionally effective for towing heavy or awkward loads in reverse, a capability rare among machines of its size. Nebraska Tractor Test Lab data records the Xerion 5000's maximum drawbar pull at 43,378 pounds force, 193 kilonewtons, placing it firmly in the upper tier of standard frame tractors. In the field, that translates into the ability to handle 12-meter cultivators, multi-section planters, and loaded grain trailers across variable soil conditions. On the road, its stability and equal weight distribution make it a capable hauler for low loaders carrying prefabricated building modules, bridge sections, or industrial tanks, especially where tracked machines would damage pavement. The cab itself is designed for year-round comfort and control. The panoramic glass offers near uninterrupted visibility, and the CBIS control interface integrates touchscreen and dial controls for transmission settings, hydraulics, and guidance systems. With hydraulic capacity up to 400 liters per minute, the Xerion can run the most demanding modern implements without auxiliary power units. Factory-fit GPS and isobus compatibility make it fully integrated into precision farming systems. In the market, the CLAAS Xerion 5000 occupies a unique niche. It competes with the likes of the Fendt 1000 Vario series and high-end John Deere 8R/9R models, but its combination of power, road speed, and multi-position cab versatility sets it apart. New units can exceed $600,000 US dollars depending on the configuration, and their substantial resale value is driven by demand from both agricultural and municipal sectors. For operators who need a single tractor to plow, haul, push, and transport, often in the same week, the Xerion 5000 offers a level of adaptability that few rivals can match. It is a rare example of a flagship machine whose engineering serves not just peak performance, but true multi-role capability in the demanding landscapes of modern agriculture and industry. Ranked 8th, John Deere 9.670RX. In large-scale farming, traction is everything. Even the most powerful tractor will falter if it can't keep its power connected to the ground, especially when working heavy soils or operating in narrow planting and harvesting windows. The John Deere 9.670RX was designed as the ultimate answer to that problem, combining the highest horsepower rating in Deere's agricultural lineup with a 4-track system engineered to maximize contact, reduce slip, and minimize compaction. Introduced in 2015 as part of Deere's 9RX series, the 9.670RX is powered by the Cummins QSX15, a 15-liter inline 6-cylinder turbocharged diesel producing 620 rated horsepower and over 2,050 pound-feet of torque. This industrial-grade engine has a long track record in mining, construction, and heavy transport applications. And in the 9.670RX, it's paired with Deere's E18 PowerShift transmission. The transmission's efficiency manager automatically matches engine load to ground speed, helping operators maintain optimal fuel efficiency under varying conditions without sacrificing pulling force. What sets the 9.670RX apart is its Quadtrac undercarriage. Each track assembly has its drive sprocket, mid-rollers, and idlers, distributing the machine's weight over a far greater surface area than dual or triple wheels could achieve. The result is significantly lower ground pressure, enabling the tractor to operate earlier in the season when soils are still wet, or in fields where wheeled tractors would sink or slip. On uneven terrain, the independent suspension of each track module maintains complete contact, further improving stability and traction. At the Nebraska Tractor Test Lab, the 9.620RX achieved a maximum drawbar pull of 48,485 pounds force, 216 kilonewtons. In the field, that translates to the ability to pull 24-row planters, 60-foot cultivators, or massive air seeders across challenging soil conditions without excessive slip. For deep tillage or subsoiling, it maintains steady forward motion under loads that would bring smaller tractors to a halt. Outside of agriculture, the same attributes make it a capable hauler for heavy industrial modules, mobile infrastructure units, or prefabricated building sections, particularly on unpaved or soft ground. Operator comfort is not an afterthought. The Command View 3 cab offers a panoramic view over the tracks. At the same time, the Command Arm control console and Generation 4 Command Center display integrate all primary functions, from hydraulic flow settings to GPS guidance and variable rate application control. The Quadtrac suspension system reduces vibration and shock transfer, making long hours under load more manageable. In the market, the 9.620RX competes directly with Case 1H's Quadtrac 620 and New Holland's T9 SmartTrack series. Still, Deere's precision Aggie ecosystem, including JD-Link connectivity, section control, and machine sync, gives it an edge for operations that require integrated technology. New units can approach $700,000 depending on options, and their resale values remain high in North America and Australia due to demand from large grain, cotton, and canola operations. The 9.620RX represents the culmination of John Deere's high horsepower design philosophy, maximum engine output, delivered consistently through an advanced track system that keeps the machine moving in conditions where wheels cannot compete. For operations where downtime isn't an option and traction is the limiting factor, it's not just a tractor. It's a guarantee that the job will get done, no matter how heavy the load or how challenging the ground. Ranked 7th, Versatile 610DT. Canada's prairie agriculture has always demanded big, simple, and reliable machines. In these vast open fields, stretching across Manitoba, Saskatchewan, and Alberta, farmers need equipment that can pull the widest implements for long hours day after day with minimal downtime. The Versatile 610DT is the modern evolution of that philosophy, a high-horsepower track tractor designed to combine raw pulling strength with straightforward mechanical design, serviceability, and year-round durability. The 610DT sits near the top of Versatile's Delta Track lineup, powered by a Cummins QSX15, a 15-liter, 6-cylinder, turbocharged diesel producing 605 peak horsepower and more than 2,050 pound-feet of torque. This engine is a workhorse of the heavy machinery world, known for its longevity in mining trucks, industrial haulers, and large agricultural tractors. In the 610 DT, it is paired with a proven Caterpillar TA22 powershift transmission, delivering 16 forward and 4 reverse speeds. This combination allows the tractor to maintain steady pulling power in heavy draft applications, whether deep ripping compacted clay or hauling loaded grain carts over soft ground. The DT in its name stands for Deltatrac, Versatile's Quadtrac system. Like the John Deere 9.670RX and Case YH Quadtrac designs, it uses 4 independent track modules, each with its large drive sprocket, mid-rollers, and idlers, to spread the tractor's weight over a larger footprint. This reduces ground pressure and slip, enabling earlier field access in wet conditions and minimizing compaction that can damage yields. The system also improves ride quality over rough ground, an essential factor during long working days in the cab. Nebraska Tractor Test Lab evaluations place the 610 DT's maximum drawbar pull at around 51,500 pounds force, 229 kilonewtons, putting it firmly in the elite class of modern agricultural tractors. In the field, that kind of tractive effort means it can run 18-meter cultivators, large seeders, or multi-section chisel plows at full working depth without bogging down. In specialized heavy haul situations, the same pulling power has been used to move prefabricated farm buildings, bulk fuel tanks, and even bridge components across job sites, all while keeping the load stable on soft or uneven ground. Inside, the cab is designed around operator comfort and ease of use. Large windows offer near 360-degree visibility, while an air suspension seat and ergonomic controls reduce fatigue. Versatile has maintained a more straightforward, more mechanical control philosophy than some of its competitors, a trait appreciated by operators who prioritize durability and serviceability over complex electronics. That said, the 610 DT can be equipped with modern precision agriculture tools, including GPS auto steering, ISO/BUS implement control, and telematics for fleet management. On the market, the versatile 610 DT appeals to large-scale operations that need high horsepower without the premium price tag of some European competitors. New units are generally priced lower than equivalent Deere or Case IH models, and their reputation for mechanical simplicity keeps maintenance costs predictable. In North America, especially in Canada, they're a common sight during seeding and harvest seasons, and in Australia, they've gained traction in broadacre cropping regions where reliability is paramount. The 610 DT carries forward the Versatile brand's decades-long reputation, straightforward, strong, and built to work. In an era where many flagship tractors are loaded with advanced electronics and complex systems, the 610 DT proves there is still a place for a high-horsepower track machine that focuses on what matters most, putting maximum power to the ground and keeping it there until the job is done. Ranked 6th, John Deere 9.670. When John Deere introduced the 9.630 in 2007, it wasn't just another high-horsepower machine. It was the largest wheeled tractor the company had ever built, and in many ways, the final representative of an era. This was the last flagship Deere designed before the full integration of electronic engine management, digital hydraulics, and advanced telematics became standard. In other words, it was the closing chapter for a breed of machines built with an emphasis on mechanical robustness first and electronics second. The 9.630 came from the factory with a Cummins QSX15, a 14.9-liter inline-six turbocharged diesel, tuned for 530 rated horsepower and more than 2,050 pound-feet of torque. The engine was mated to Deere's 18-speed complete power-shift transmission, a tried-and-tested driveline built to deliver uninterrupted torque in continuous heavy draft work. This pairing was chosen not for cutting-edge efficiency, but for absolute dependability under load, a priority for operators pulling the heaviest implements available at the time. Fully ballasted, the 9,630 tipped the scales well above 24 tons, and at the Nebraska Tractor Test Lab, It posted a maximum drawbar pull of 53,666 pounds force, 239 kilonewtons. In practice, that meant running 60-foot field cultivators, deep rippers, or massive air seeders with consistent forward speed in even the toughest soils. In specific industrial applications, operators adapted the 9.630 to tow prefabricated buildings, large grain silos, and modular infrastructure sections across hard-packed or gravel bases, taking advantage of its articulation and traction. The articulated chassis was key to this versatility. With duals or triples on all axles, the 9.630 maintained contact and stability while steering, spreading its weight to minimize compaction and maximize grip. Unlike the Quadtrac machines that would soon rise in popularity, the 9.630's wheeled setup allowed faster road travel between fields while avoiding the higher maintenance costs associated with track systems. Inside the command view 2 cab, the layout reflected its transitional status. Mechanical levers and robust toggle switches shared space with Deere's Green Star Ready harnesses, allowing for GPS guidance integration without making it a fully electronic-dependent machine. Visibility was excellent thanks to the wide glass area, and hydraulic flow, over 115 gallons per minute, meant compatibility with the most demanding air seeder and planter systems on the market at the time. In the marketplace, the 9.630 was aimed squarely at operations that wanted brute pulling power without moving to track systems or more electronically complex platforms. Competing with Case IH's Steiger 535 and New Holland's T9.670, it carved out a loyal following, especially in North America and Australia. Even today, clean low-hour units can sell for $200,000 or more, valued by farmers who appreciate their mechanical simplicity, substantial resale value, and ease of maintenance. Looking back, the John Deere 9.630 stands as both a peak and a pivot point, the most powerful of Deere's mechanically dominated flagships, and the bridge to the modern, electronics-heavy 9R series. It's remembered not just for what it could pull, but for being the last of its kind before the industry fully stepped into the digital age of high-horsepower agriculture. Ranked 5th, New Holland T9.670 wheeled. In the T9 series, every model is built for scale, but not every operation needs the absolute top-end horsepower. The New Holland T9.670 exists in that deliberate middle ground, powerful enough to handle the heaviest field work most farms will ever attempt, but without the fuel demands and purchase price of the flagship T9.700. For many operators, it's the sweet spot. All the pulling muscle they need, paired with road speed, maneuverability, and a lower cost per hour. At its core is the FPT Cursor 13, a 12.9-liter, 6-cylinder turbocharged diesel tuned to deliver around 608 peak horsepower and over 2,050 pound-feet of torque. This engine is known for its fuel efficiency and long service intervals, both critical for operators who put hundreds of hours on their tractors each season. Power flows through a robust 16-speed complete power shift transmission, giving consistent torque delivery under maximum load and precise control at slow working speeds. The T9.670's articulated chassis and dual or triple wheel setups make it a specialist in wide implement work. With a fully ballasted weight exceeding 24 tons, Nebraska Tractor Test Lab figures place its maximum drawbar pull in the 54,000 to 55,000 pounds force, approximately 242 kilonewtons range. That's enough to draw a 70-foot cultivator, a multi-section air seeder, or a deep ripper at full working depth without sacrificing ground speed. Outside of farming, that same pulling capacity has been applied to moving prefabricated steel structures, large fuel tanks, and mobile industrial units across compacted dirt or gravel bases. Being a wheeled platform, the T9.670 offers advantages in transport that track systems can't match. It can travel at higher road speeds, up to 30 kilometers per hour, between distant fields, and tires are less costly to maintain than track belts. This matters for contractors who move frequently between jobs and for farms spread across large geographic areas. The cab is designed for long shifts and straightforward control. New Holland's Sidewinder 2 armrest groups transmission, hydraulics, and implement controls within easy reach, while the large, high-mounted cab provides a clear view over wide implements and field edges. Hydraulic capacity exceeds 113 gallons per minute, more than enough to power air carts, precision planters, or high-demand hydraulic tillage tools. In the marketplace, the T9.670 competes with wheeled versions of John Deere's 9R series and CLAAS IH's Steiger 580. It often wins favor with operators who want the most horsepower they can justify without overspending on a flagship they'll never fully load. Priced in the $550,000 to $600,000 USD range when new, it offers a combination of pulling strength, operating economy, and serviceability that keeps resale values strong in wheat, corn, and soybean regions worldwide. For many large farms, the T9.670 represents the point where power, cost, and versatility align. It's a machine that can spend one day deep ripping hundreds of hectares, the next hauling silage or grain carts, and still be ready to hook onto a building mover's trailer when the job calls for it, all without the compromises that come from chasing maximum horsepower at any cost. Ranked fourth, CLAAS IH Steiger 620. Quadtrac. Before the Quadtrac system, high horsepower tractors faced a trade-off. Wheeled models, even with triples, could lose grip and cause deep compaction under heavy draft loads. Two-track crawlers offered better flotation, but steering under load often produced power hop, a loss of traction and stability during turns that slowed work and strained drivetrains. The CLAAS IH Steiger 620 Quadtrac was engineered to remove that compromise. Its design uses 4 independent track modules, each mounted on its pivoting undercarriage. This allows every track to maintain complete ground contact while turning, eliminating the binding and soil ridging seen with two-track systems. The layout spreads the tractor's mass across an enormous footprint, reducing ground pressure while keeping tractive effort high, especially important in spring and autumn when soil moisture is high. Powering the 620 Quadtrac is the Cummins QSX15, a 15-liter, 6-cylinder turbocharged diesel rated at 620 horsepower and producing more than 2,050 pound-feet of torque. The engine is mated to a 16-speed, full power shift transmission, capable of holding peak torque through long, continuous pulls. In Nebraska tractor test lab trials, the 620 Quadtrac achieved a maximum drawbar pull of 57,556 pounds, force 256 kilonewtons, enough to operate implements such as 80-foot cultivators, multi-section air drills, or deep rippers in heavy soils without losing forward speed. Beyond farming, this combination of low ground pressure and high tractive effort makes the 620 Quadtrac useful in roles where traditional prime movers would sink or stall. In construction and heavy haulage, it has been used to move prefabricated building sections, large tanks, and even bridge modules across unfinished or soft ground. The Surveyor cab is built for long operational windows with panoramic visibility, suspended seating, and the multi-control armrest grouping key transmission, hydraulic, and guidance controls. Up to 113 gallons per minute of hydraulic capacity means compatibility with the most demanding modern implements in factory AFS, Advanced Farming Systems. Integration provides GPS guidance, variable rate control, and data logging. In the market, the 620 Quadtrac sits at the top of CLAAS IH's high horsepower lineup, often chosen by operators working in high moisture clay soils or on steep terrain where wheeled tractors can't maintain traction. New units can exceed 700,000 US, but they retain value due to their ability to keep working when ground conditions sideline other machines. The Steiger 620 Quadtrac didn't just add more horsepower, it redefined how that horsepower could be applied to the ground. By eliminating the steering and traction compromises of earlier designs, it set a standard for consistent, controllable pulling power in conditions that defeat most other high horsepower tractors. Ranked third, Big Bud 16B747, Extended Professional Segment. In 1977 in Havre, Montana, a custom order from a cotton farm in California led to the creation of what remains the largest agricultural tractor ever built, the Big Bud 16V747. Unlike every other machine in this lineup, it was never part of a model range, never marketed for mass sale, and never duplicated at scale. It was a one-off solution to a singular request. A tractor that could pull the widest cultivators available at full working depth, hour after hour, in some of the heaviest soils in North America. At its heart is a Detroit diesel 16x92T, a 16-cylinder, two-stroke, turbocharged diesel producing 760 horsepower in its original configuration. The engine's industrial origins are evident in its construction. 4 turbochargers, massive wet sleeve cylinders, and a design adapted from heavy-duty marine and mining applications. Power is channeled through a custom-built gear train and a heavy-duty 6-speed twin-disc power shift transmission designed to survive the enormous torque output without failure. Weighing in at over 45 tons fully ballasted, the 16V747 delivers a maximum drawbar pull over 58,000 pounds force, approximately 258 kilonewtons. The tractor was explicitly designed to operate with an 80-foot wide chisel plow, moving at 8 miles per hour, working over 1.3 hectares per minute in optimal conditions. Its frame, built from welded steel plate rather than castings, was fabricated in Big Bud's Havre facility, allowing custom reinforcement around the articulation joint to handle extreme side loads. The machine's scale is not just for show. Its massive 8-wheel setup, each wheel fitted with 8-foot-tall Goodyear LSW low sidewall agricultural tires, spreads its weight to reduce soil compaction despite its size. The cab, mounted high above the frame, offers a commanding view of the implement and the field ahead, with controls laid out for long days in the seat. Although comfort, in late 1970s terms, is far more basic than modern high-horsepower tractors. The 16V747 worked for decades in California and later in Montana, proving that its design was not just a publicity statement. Maintenance was entirely manual and component-based. The engine could be rebuilt in the field, and the transmission could be swapped without factory intervention. This mechanical serviceability, combined with the overbuilt frame, meant the tractor's lifespan extended far beyond most of its contemporaries. In the global market, the Big Bud 16C747 occupies a category of one. No other production agricultural tractor has surpassed its size or original horsepower rating without venturing into purpose-built industrial prime movers. Its fame has only grown since it was retired from daily work, becoming a museum exhibit and a symbol of a time when agricultural engineering sometimes meant building exactly one machine to solve exactly one problem. Cost, mass, and standardization be damned. Today it serves as a reference point in discussions about scale in agriculture. Even with modern 600-plus horsepower articulated tractors, nothing has matched the 16V747's combination of physical size, implement width, and sustained field output. It remains an engineering outlier, not a commercial product, but an agricultural legend forged from industrial parts, local fabrication, and the singular vision of a farmer who wanted the biggest tool the field had ever seen. Ranked second, New Holland T9.700, extended professional segment. At the very top of New Holland's articulated tractor lineup sits the T9.700, a machine built for one purpose, delivering the maximum horsepower available in a factory agricultural chassis without stepping into custom or industrial conversions. It is the model operators choose when even the T9.670's 608 horsepower isn't enough, and every additional implement section, every extra working meter, and every minute saved per pass matters. Under the long, squared-off hood is the FPT Cursor 13, tuned to an output of 682 peak horsepower and a torque curve exceeding 2,200 pound-feet. While it shares its basic engine architecture with smaller T9 models, the 700's calibration, cooling capacity, and driveline reinforcement are unique, allowing it to sustain full power under continuous heavy draft loads. The 16-speed complete power shift transmission is paired with a heavy-duty final drive, set designed to handle the stresses of pulling implements well beyond 25 tons of draft resistance. In the Nebraska Tractor Test Lab, the T9.700 has recorded a maximum drawbar pull approaching 58,000 pounds force, approximately 258 kilonewtons. In practical application, it can run the widest air seeders, multi-section cultivators, or subsoilers at depth without speed loss, even in high-resistance soils. Contractors have adapted it for industrial moving tasks, where its articulation and ballast capacity allow it to tow modular buildings or bridge spans across compacted dirt or gravel haul routes. Unlike the T9.670, the T9.70 is almost always ordered with the heaviest ballast packages, pushing its operating weight beyond 25 tons. This mass, combined with dual or triple tires on each axle, gives it both the stability and traction to convert its extreme engine output into consistent forward motion. The wheeled configuration also offers an advantage in road transfer speeds, reaching up to 30 kilometers per hour between work sites, a critical factor for large operations covering hundreds of square kilometers. Inside, the high-mounted cab follows the same Sidewinder 2 layout as other T9 models, but with refinements targeted at long-shift operators, enhanced climate control capacity, premium suspension seating, and integrated precision farming controls. Hydraulic flow can exceed 113 gallons per minute, enough to run multiple high-demand implements simultaneously, including air carts with separate hydraulic drives. Market positioning for the T9.700 is straightforward. It is New Holland's power ceiling. It competes directly with CLAAS IH's Steiger 620 wheeled variant and John Deere's 9R640, appealing to buyers who require maximum field output per pass. New units typically sell in the 620,000 to 680,000 USD range, depending on specification, and they hold value best in regions where extreme implement widths are standard practice. The T9.700 is not designed for the average farm. It's a specialist tool for the most extensive acreages, the heaviest implements, and the shortest operating windows. For those conditions, there is no higher rung on New Holland's ladder. In first place, Buhler Versatile 1150. The centerpiece of the Versatile 1150 is not its frame, cab, or even its pulling capacity. It's the engine. A Cummins KTA 1150, 19 liters of displacement, 6 cylinders the size of paint cans, and a turbocharger system designed for mining trucks and marine tugs. In most applications, this engine moved hundreds of tons of rock or steel. In 1150, it moves steel, soil, and seed. Factory rated at 470 horsepower and capable of field tunes well above 500, the KTA delivered more than 1,650 pound-feet of torque at low RPM. Coupled to a heavy-duty power-shift transmission and planetary final drives, that torque reached the ground through massive dual tires on each axle. Fully ballasted, the tractor weighed over 20 tons and could sustain drawbar pulls exceeding 45,000 pounds, force approximately 200 kilonewtons, without overheating or losing speed. The frame was a welded box section design with no wasted material. Service points were wide open, with the KTA accessible for in-frame rebuilds, a vital feature for operations far from dealer workshops. Fuel consumption was high, but so was field coverage. With the proper implement, the 1150 could prepare more than 250 acres in a single day under ideal conditions. The cab reflected its era, high-mounted for visibility, with straightforward mechanical controls and minimal concessions to comfort. Air conditioning was available but basic, and most of the soundproofing came from heavy steel panels rather than acoustic engineering. For its operators, the priority was not luxury, it was the ability to run wide implements at full working depth for as many hours as daylight allowed. When introduced, the 1150 stood in rare company. Few factory-built tractors worldwide had crossed the 500 horsepower threshold, and none combined that power with the simplicity and field serviceability of a Versatile. It became a favorite in the Canadian prairies and U.S. Midwest, where enormous, flat fields demanded fewer passes and faster work. The Buhler Versatile 1150 was not just another step in tractor evolution. It was a statement that agricultural machines could borrow directly from the industrial sector, scale up power without overcomplicating the platform, and give operators a tool that could outlast multiple generations of smaller tractors. Even today, well-maintained examples are still working the land, proof that the straightforward approach can stand the test of decades. From purpose-built giants with engines measured in dozens of liters, to modern production models fine-tuned for maximum efficiency, each tractor on this list stands at the edge of what is mechanically possible in agriculture. Their power is not just a number on a spec sheet. It is the ability to move immense loads across soil, gravel, or asphalt with precision and control. In the hands of skilled operators, they become more than farm machines. They are mobile platforms capable of reshaping land, shifting infrastructure, and performing work that blurs the line between agriculture and heavy industry. The environments that require this level of capability are rare. Vast acreages, high-resistance soils, or the transport of structures too large for conventional haulage. But when those challenges appear, the solution is not theory. It is steel, torque, and traction, applied without compromise. The tractors shown here are proof that in the pursuit of productivity, scale itself becomes a tool. And in that pursuit, there will always be a next boundary to push. Let us know which one resonates with you in the comments, and don't forget to like and subscribe to our channel for more content like this.